Good day, students and viewers, and compliments of the season. You are welcome to the studios of Maths X. Today, we will be learning about swords. Swords. First of all, a sword is a number. A sword is a real number. There are two types of numbers in number systems, the real and the imaginary. For today, we will be dwelling on real numbers. We'll save the imaginary numbers for another day. Then for the real numbers also, there are two types of real numbers. That is the rational and the irrational numbers. Let's put this down on the board for better understanding. So for real numbers, I said there are two types of real numbers, and that is the rational and the irrational numbers. For the rational numbers, let me start from there. Rational numbers are numbers that can be written in ratio forms. They can be expressed in ratios. Ratios are fractions also. So let's talk about rational numbers. These are numbers that can be expressed in ratios, as in ratios of possibly like A over B. So rational numbers are numbers, they are real numbers that can be expressed as ratios. And take note that this A and B must be integers. Very important, they must be integers. They must be integers. And of course, another rule is that B must not be 0. Very important about rational numbers. Examples of rational numbers are all integers. So we're talking about numbers like -2, 1, 3, and 4. Now, you may be asking a question. How are these numbers ratios? Very simple. What if I do this? Over 1, over 1, over 1, over 1. This is -2 over 1. This is 1 over 1, 3 over 1, 4 over 1. See, they can be expressed as ratios. Another examples of rational numbers are fractions. When I say fractions, I'm talking about mixed fractions, proper fractions, and improper fractions. So fractions like 3 over 4 are rational numbers. Maybe improper fractions like 7 over 6 are rational numbers. Maybe mixed fractions like -3 whole number 1 over 4. These are also rational numbers. Having said that about what rational numbers are, there are also two types of rational numbers. And for these two types of rational numbers, one of them is the terminating rational numbers, and the non-terminating and recurring rational numbers. Let me explain these. For the terminating rational numbers, I'm referring to numbers like, for the terminating, rational numbers, I'm referring to numbers like 3 over 4. 3 over 4 is 0.75. See, the decimal terminates. Or maybe even 1 over 4. 1 over 4, I'm talking about 0.25. It stops somewhere. Maybe lastly, I'll give this to you. How about 1 over 5? 1 over 5 can be expressed as 0.2. These are terminating rational numbers. Let's look at the non-terminating and recurring rational numbers. What kind of numbers are these? Have you ever tried doing a long division? And when you did the long division, you made a funny observation. The number never seems to end in its decimal form. Did you observe that? If you're not sure, I'll give you a number. Look at a number like 1 over 3. At home, try it out. Try to divide it using long division. You will make a funny observation. You can just go on and on and on with that piece of maths you're trying to do, and it never seems to end. You're just going to have to stop somewhere. If you're using a calculator, it will make an approximation for you. So for numbers that are non-terminating, and recurring rational numbers, I'm looking at, like I said earlier, numbers like 1 over 3. 1 over 3 is 0.333 dot 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 till infinity. A neater way of writing this would be 0.3 with a slash on top. This makes your examiner know that you are writing a recurring decimal number. So this is a rational number that is non-terminating and the recurring type of rational number. There are others, of course. How about numbers like 2 over 9? 2 over 9 is 0.222 dot 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 dot. It goes till infinity. It can also be written as 0.2 with a slash on top. How about numbers like 3 over 11? 3 over 11 is 0.272727 dot 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 till infinity. Easier written as 0.27 with a slash on top. This makes your examiner or anybody following you to know that this is a non-terminating recurring rational number. Now that we are done talking about the rational numbers and of course the two types of rational numbers, the terminating rational numbers and the non-terminating rational numbers, let us talk about the irrational numbers. For the irrational numbers, these are the exact opposite of what the rational numbers are. These are numbers that cannot be expressed as a fraction or as a ratio. A star feature of an irrational number is that it is non-terminating, and non-recurring. That's one star feature of it. I think I should put that down. It's very important. It is non-terminating, and non-recurring. I told you earlier they cannot be expressed as ratios. So for this sort of expressions, an example of this would be numbers in square roots. Numbers in square roots like square root of 2. Numbers in square roots are called surds, which is what our topic here today is. Square root of 2 has a value of 1.4142 dot 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 till infinity. It does not stop. How about other square roots like root 3, 1.73205 dot 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 till infinity. Of course, there are other examples of sorts. I might not give you their values again. Root 5, root 6, and they go on and on and on. Now, surds are not the only rational numbers. They are not. There are other rational numbers like the ratio of the circumference of a circle to its diameter, like pi. Pi has a value of 3.1415956 dot 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 dot. Of course, till infinity. Sorry, it's a 2 here. 926 till infinity. There are other irrational numbers like the Euler's number is called E. E has a value of 2.71828. And there's another kind of irrational number. That one is called the golden ratio. The golden ratio has a value of 1.618033 till infinity. So these are examples of irrational numbers. So having said all this, what is a sword? It's good we have a definition for what a sword is for my dear students and viewers. So a sword is the nth root of a natural number which gives or yields an irrational number. That's what a sword is. And going by this particular definition, we have the nth root of an expression like x. So that a sword is the nth root of a natural number which gives or yields an irrational number. So going by this, that this is the nth root of x, of course, and the result must be what? Irrational. So if the result gives you a rational result, then the number is not a sword. So what I just said now, let's look at square root of 2 is a sword. Square root of 5 is a sword, in that the numbers are decimalized, are numbers that are non-recurring and non-terminating, right? But what if I have a number like square root of 4? Square root of 4 is 2, and 2, this is not a sword, in that 2 is a rational number. So we said that that it yields a what? Irrational number. So where the nth root of a particular natural number yields a rational number like 2, that is not a sword. How about cube root of 8? It's also 2. This is also not a what? A sword. So not all numbers that are in square roots or that are in roots are swords. There are some that are not swords, like these last two that I just showed you. But the first two up there, these ones are swords. So let us analyze what a sword is based on this definition. For this, the N here is called the order of the sword. The root sign here is called the radical. And then our x here is called, let's put it up here, the radicand, or maybe the base. Let's put real numbers in here. So where I have cube root of 5, our 3 here, of course, like I said earlier, is the order of the sword. The square root sign here is the radical. And of course, our 5 is the radicand. The radicand, or the base of the sword. So, my dear students and viewers, in our next video, we will delve deeper into swords. Until then, keep watching the videos of Maths X, like, subscribe, and share with your friends. As you do so, God bless you.